Have you ever wondered what would happen if you use the value counts method on a series twice? Probably not, because that's a relatively random thing to think about. But after watching this video, you will leave with a strong understanding of how the pandas series value counts method works and of how to think about pandas data structures more generally. So, what does the value counts method do? As I just mentioned, it's a series method, which means the thing before .value counts needs to be a series data structure in pandas. So to illustrate, I've presented us with an example series called EX here with 13 elements in it. Some of them are equal to 1, some are equal to 2, some are equal to 5, some are 12, and some are 19. The values of the series are shown over here on the right. The numbers on the left constitute the index of the series, which give a name or label to every element in the series. So what would happen if we called the value counts method on this example series? Well, what it does is it gives us the count or frequency of every unique value in the series. So let's try and predict the behavior of calling value counts here. The output will tell us all of the unique values, so I'll write a little value column here, as well as the frequencies or counts of all of those values. What are the unique values in this series? Well, as we enumerated before, they are 1, 2, 5, 12, and 19. So those values, 1, 2, 5, 12, and 19, are going to be in the index of the new series that we get after calling value counts. What are the actual values in that series going to be? Well, they're going to be the counts or frequencies of 1, 2, 5, 12, and 19. So how many 1s are there? I just see 1. How many 2s are there? I see 4. How many 5s are there? 2. How many 12s are there? Again, I see 4. And how many 19s are there? I see 2. So ultimately, this information is what the value counts method is going to show us when called on this series EX. Now, one nuance is that the value counts method automatically sorts by the frequencies or counts. So when we call value counts on example here, we're not going to see 1, 4, 2, 4, 2, which is what we would get if it's sorted by the index by default. Instead, we're going to see something like 4, 4, 2, 2, 1. And to try it out, let's just run this cell and see what we get. Indeed, we get 44221. Again, the values in the index correspond to values from the original series, and the actual values in the series 44221 correspond to the frequencies of 2, 12, 5, 19, and 1. So notice, after we've called value counts on the series EX, we've gotten back another series. And since we've gotten back another series, we can use any series methods we want on that resulting series, including calling value counts on that same series once again. And so something to think about is what would happen if we call value counts on the result of value counts? Well, we'd follow the same process. The resulting series would tell us the counts or frequencies of every unique value in this series. What are the unique values? 4, 2, and 1. And how often do they occur? Well, there are 2 4s, 2 2s, and 1 1. Okay, so if we call value counts on the result of calling value counts, what we're going to see is something like this. And indeed, we can verify that that's the case by running this cell, and we see exactly what we had predicted. Now, the question is, how do we get back the original series example using the result of calling value counts twice? In other words, how do we work backwards? If all we get to look at is this expression's output, if we only get to look at this, how do we get back that initial series? Well, let's try and reason about it. Let's think about what it would mean to unroll, and I'll put that in quotes, the value counts. What that means is, given the result of a call to value counts, how do I get back the original series it was called on? In this case, how do I get back the series example? Oops, didn't mean to move myself around here. How do I get back the series example.value counts? Well, in order for things to end up in the index after calling value counts, they had to be in the values or on the right side of the original series. Okay? And so what this is telling me is on whatever series I called value counts on previously, what I had were 2 4s, 2 2s, and the value 1. So this series that I've underlined here, that is the thing that I called value counts on most recently, had to look like 4 4 2 2 1 in its values. Unfortunately, once we call value counts, we lose the information that was in the index of the original series. So this original series here, its index was something like 5, 12, 19, 2, 1, or something like that. But just by looking at the output of example.valueCounts.valueCounts, there's no way of figuring out what that index was supposed to be. So I'll just, fill in some placeholder values like A, B, C, D, E. Okay? So this is what example.valueCounts looks like in terms of its values. We don't know what the index of it would have been. Now I can unroll my value counts one more time to infer what the original series would have looked like. The original series would have had some value A 4 times. Again, we don't know what A exactly is. It would have had some other value B 4 times. It would have had C twice, D twice, and then an E. Okay? So we don't know what the exact values in the original series here, example, were, but we know that there were 2 unique values, both of which occurred 4 times. There were 2 unique values, each of which appeared twice, and then 1 value that was just there on its own. So that's how we can learn something about the original series by interpreting the results of valueCounts.valueCounts. Let's try and use a more concrete example that involves real data. Okay, so we're going to work with the dogs data set that we started working with in lecture 4. And what I've presented here is the result of calling value counts twice on the kind column. If we take a look at this data frame preview, the kind column tells us the general category of each of these dog breeds. Okay, and I'm intentionally not looking at the entire kind column, though I do have access to it because dogs is a variable defined in my notebook. So the question is, what does the kind column look like if all I'm allowed to look at is this output right here? Well, let's once again try and unroll the value counts, okay? And in this case, we're unrolling the double value counts to get to the single value counts, and then we'll try and unroll that once again to get an understanding of what the original series looked like. So if we unroll this once, well, this is telling us the value 2 occurred twice, the value 12 occurred once, and then 8, 7, 6, and 5, those all occurred once as well. So in dogs, the kinds column value counts, that is the single value counts, these are the frequencies. And the actual kind values would have been in the index, but I'm not allowed to look at the actual kind values. Okay, I know from the data frame preview that there's something like sporting, working, terrier, things like that, but for right now, I don't know what those actually are, so I'm going to fill these in with some placeholders. And remember, the actual output, if I looked at dog square brackets kind.value counts, wouldn't look like this. One, it would have actual kind values instead of A, B, C, D, but it would also be sorted by the values of this series. So 12 would be at the top, then 8, then 7, then 6, then 5, with 2 and 2 at the very bottom. So what this is telling me is that the original kind column, so if I unroll again, it's going to look something like C, C, C 12 times, followed by D, D, D 8 times, and so on and so forth. So it's telling me if I were to look at the original kind column and sorted it in some order, I would see 12 of one thing, followed by 8 of another, followed by 7 of another, 6 of another, 5 of another, and then 2 of one thing, and then 2 of another. Okay? I, again, don't know what the actual kinds are, but I know how often they occurred. And that's how I would unroll a double value counts to a single value counts, which is what I'm looking at here, and then use that to unroll once again and infer something about the initial data set. And just so that we look at something concretely here, I can go ahead and remove this second value counts and look at the results of just the one value counts, and you see those same values that we had before. There's 2 kinds, both of which occurred twice, herding and non-sporting in this case, and then one kind that appeared 12 times, one kind that appeared 8 times, one that appeared 7, 6, and 5. And then if I peek at the initial series, well, it's longer than we're able to look at, but somewhere in here we will see, say, 12 sporting breeds. 1, 2, 3, so on and so forth. And we will see herding twice and non-sporting twice, for instance. And we knew that this is what the series would look like by unrolling the double value counts twice. We just didn't know what the actual breeds were. But sometimes in data science, we don't need to know the actual category names. We just need to understand their distribution or frequencies. And unrolling a double value counts expression can be super helpful in understanding how that data looks. So thanks for watching this video. Let me know if you have any feedback for it, and happy data sciencing.